What if I told you that every building around you is basically a carefully controlled way of cheating gravity? Some buildings do it with hidden frames, some with stiff concrete cores, some by hanging parts of the structure in tension, like a giant upside-down bridge. And the reason this matters isn't just engineering trivia. It decides how tall a building can be, how safe it is in an earthquake, how open the floor plan feels, and even how much it costs to build. So today, let's look at 5 fascinating ways buildings stand up. First, load-bearing walls. This is the oldest and simplest system. The walls do the hard work. They carry the weight of the floors and roof down into the ground. The mechanism is straightforward. Gravity pushes down. The wall spreads that force out into the foundation. The thicker the wall, the more load it can usually handle. This is useful because it's simple, durable, and often cheaper for low-rise buildings. Think houses, older apartments, or small masonry buildings. But there's a trade-off. Since the walls are doing the structural work, you can't just remove them whenever you want. Open floor plans become harder, and windows and doors have to be placed carefully. Next is the frame system, also called post and beam. Here, columns carry vertical load and beams transfer it across open spaces. Instead of the walls holding everything up, the skeleton does. That means the walls can become curtain walls, basically weather shields rather than structure. This is incredibly useful in modern design because it gives flexibility. You can reconfigure interiors, create large open rooms, and use huge glass facades. A concrete example. Office buildings often use this system, so tenants can rearrange spaces without rebuilding the whole structure. Now let's add another problem. Buildings don't just get pushed down, they get pushed sideways by wind and earthquakes. That's where shear walls come in. Shear walls are stiff vertical walls, often made of reinforced concrete, that resist lateral movement. They work by acting like a rigid spine, preventing the building from swaying too much. Why is that useful? Because too much sway can crack finishes, damage structure, or even cause collapse in severe events. You'll often find shear walls around stair cores, elevator shafts, or the center of a tower. In practice, they're one of the main reasons tall buildings feel solid instead of wobbly. The fourth system is one of the coolest, tube structures. Instead of a building relying on a few interior columns, the outer edges behave like a hollow tube, resisting wind by distributing forces around the perimeter. Think of it like holding a cardboard tube versus a single sheet of paper. The tube is much harder to bend. This is hugely useful for tall buildings because wind loads become a major challenge as height increases. Tube systems make skyscrapers stiffer without needing giant columns everywhere inside. A real-world example. Many super tall towers use variations of this idea because it helps them rise higher while keeping the interior usable. And finally, the opposite of the usual idea. Some buildings are supported partly by tension. Instead of only pushing forces down through compression, certain structures use cables or suspended floors to hang parts of the building from stronger elements above. This is useful when you want dramatic spans, unusual shapes, or fewer columns on the ground. The mechanism is simple but powerful. Tension members pull instead of compress, which lets engineers create very lightweight-looking spaces that are still strong. You'll see this idea in dramatic atriums, bridges, stadium roofs, and some modern architectural landmarks. So why should you care about structural systems? Because they shape everything we experience in a building. How open it feels, how safe it is, how much it costs, how flexible the layout is, and how it performs under wind, earthquakes, and time itself. A great building isn't just the one that looks impressive. It's the one whose structure quietly solves the right problem. So the next time you walk into a building, try asking, what is really holding this up? Is it walls, a frame, a stiff core, a tube, or even tension? That hidden answer is one of the most interesting parts of architecture, because the structure is the part you usually don't notice until something goes wrong. If you want, I can also turn this into a more cinematic voiceover version or add visual cues and on-screen text for each section. 5 fascinating ways buildings stand up. Structural systems explained is just one small part of structural systems. If you're interested, our full free structural systems course is linked in the description.